Assalamu alaikum, ladies and gentlemen. Welcome back to another live stream. So we're back with part two, with Beirut. Can you introduce yourself again, Beirut?
Hey everyone, I'm a C++ developer, well, a junior one, a very new one indeed. And I am on the path to learning Rust, and I'm finding it really cool so far.
Great. So, what do you want to learn today? I do have an idea, but can you give me your own ideas first? And let me share the string, yeah?
Yeah, to be honest, I have no idea. You go for it, because I don't know exactly where you would begin learning a new language,
All
but
right.
so far it's been good.
Okay. Forgot to share the string. Here we go. Okay, seems good to me now. Let's pop out the chat. And let's go. Let's set up some live share. Okay, so live share start collaboration session. And let's go. Here's the link. Okay.
Yes.
Okay, let's wait for
Okay,
it.
I think I'm in.
Doesn't tell me. Oh, there you go. Okay, cool.
There we go.
All right, great. So let me also show it. Oh, it's already shared. Can you cargo run?
Yeah. Wait. Oh, I have to request. There we go.
Okay, what about now?
There we go.
Great. All right, so I think I'm gonna go directly into a more advanced topic today.
Okay.
Well, let's start first with a little bit of string references, because I figured I didn't really teach you a lot about string references. And then we're probably gonna go with two generics, which is the spicy part.
Okay.
Hopefully it wouldn't be too hard.
Hopefully.
Okay, so...
I mean, generics are kind of a nightmare in C++ anyway.
Well, in Rust, it's another level.
Okay.
But we'll see how it goes. All right, so can you create a function called lower, or call it lower, right?
A what?
Lower, basically lowercase.
Lower. Okay.
Right, and it would take a string.
Okay, so it would take a string such as name.
Okay, whatever. And give it a type. It's gonna be a str reference. Well, I mean, we could start simple with the string. We could start simple with string, which is of course allocated. It takes an allocation and such, which is not great, but let's start simple. And then it would return, well, of course, another string, right?
Okay. Another string, let's say upper.
String. That's just the type there, yeah. Is the stream fine, by the way? Man, can you make sure that...
Yeah.
Okay, great.
I think so, yeah.
Alright, so just try your best bet and we can go from there. Let's try our best bet first.
Well, can I just say return? Well, you said that return is not necessary, so let's just go with...
because it's the last.
Name dot to upper? No, there isn't to upper. Not to uppercase.
Cool. Alright, so can you call this with something? Print line, you know?
Let's say...
or we can help. I can teach you some tests right now, actually. I honestly do not write too much tests, so I'm not sure if I don't even remember the syntax. I'm a terrible engineer. But Let's go. Let's make a test here. So
Okay.
just remove that for now. Or
I
copy
want
it.
to see if this works.
Okay, I mean we can
This
use
is-
a test for that, right? So
Okay.
okay, so I think. Hold on, like literally, how? I think you do it like, huh? I actually literally do not remember how to do tests in Rust. The syntax. Hold on a second. Rust's test. Okay, let me see. Yeah, mode test, my bad. Okay, so write a new module. I haven't taught you modules yet, but it's basically
No.
kind of like, kind of like a translation unit in C++.
Okay.
With the namespace to some degree.
Okay.
Anyways, say mod tests
Mod test. Okay.
with an S at the end, plural, right?
A mods. Okay.
No, the test, sorry.
Ah.
Okay, so you're making a module called test. You open the block.
Okay.
There you go. Now, in up here, you're gonna say sharp, like C sharp. Hashtag, right?
Hashtag.
And
yeah.
then brackets, square brackets,
Brackets. Yeah.
and CFG. And you're gonna
DFG.
CFG.
CFG.
And you're gonna call it
Yeah.
with let's see, test, I think. Let's see.
Yes.
CFG test. Yeah, CFG test.
Yeah.
And then here you can, this is basically your kind of like your namespace for tests. And here you can
Okay.
basically make multiple tests by making functions. So you would create, let's say, fn and call the test something. So just a function, yeah. Make a new function. Call it something for
let's
that.
see.
That's going to be the name of the test.
Lower. Oops. Now we can put lower. And I'm guessing you pass a string into it.
Not really, not
Yeah.
really. You don't pass
Oh,
anything to
okay.
the tests. And yeah. Okay, so right here we could actually use, well, before that, before the fn, you also need another CFG test, I think. No,
Mhm.
you just need a hashtag square brackets test.
Hashtag test. I see.
Square brackets test. Okay, great.
Ah, nice. Okay.
Alright, so right now you have roach1 test, though it doesn't contain anything yet. So you go inside of it, and now you can try your test that you want to do. So you could use assert here.
Something like
Basically,
that?
you could use assert.
Ah, I see.
Instead of print line, you would use assert and see if you got the expected output.
So is assert just similar to?
It's a macro,
Here.
so it's gonna end in just like print line would end in yeah, exactly. Exclamation mark. And
So
you would
that's
have another
underscore.
operand, which is the expected value from that function.
Ah, I see. Okay. So it would be.
Though here, actually, you're supposed to make a condition, but you can say assert EQ instead. So you would do it
Assert
directly, and it would
EQ.
give you a better
Okay.
error message.
Guessing.
Okay.
It says cannot find function lower in the scope.
Yeah, because this is another module, so you gotta make sure to import it into this scope right here. You're gonna say use.
Use
Where is that?
and just use lower.
I honestly do not remember. Yeah, use super. Use super, and then you're gonna do exactly, and then yeah, you could do that, or you could just import everything using a star. But that's good. That's good. Fine. Okay, and the semicolon, and that should be it. All right, great. So what's the error that we have now?
Okay.
First of all.
So this has to be dot. What was it? To string?
Yeah, that's good. Wa alaikum salam wa GG Gearing. Welcome to live stream. How's it going? Welcome back.
There we go.
Yeah, or you could say into to let the Rust type
it
engine
says-
figure it out.
Into, yeah. So it says function lower is never used.
Well, right now you shouldn't use cargo run. You should. We could just remove this thing actually.
Mm-hmm.
No need for it.
Oh, do you
And
call the test?
cargo tests. Yeah, cargo tests.
Ah, okay.
So try it.
Let's see. Cargo tests.
Test, just test.
Not test, okay.
And
Okay, yeah, nice.
okay,
Passed.
one passed. You don't need a library to make tests in Rust. You already have a framework for testing.
That's cool, nice.
Great. Try to make just a mistake here so you can see how it looks if it
Yeah.
failed. There you go.
Failed, one failed. And okay. So it says the left is returning that and the right is something else. And then run with Rust bracket equal 1. Environment variable to display backtrace. Okay.
So by
Interesting.
convention, by the way, we put the right thing that we expect in the right,
Underneath it.
on the right,
Ah.
right? And on the left,
yeah.
the thing that we're actually trying. So
see,
you see, right thing is in the
Yeah.
right.
Yeah, yeah.
Yeah. All right. Great. So yeah, just keep the test as it was, pretty much.
Yeah.
Just fix it. Yeah. And there you go. Cool. So now, what is the problem in your opinion with this solution right here?
Only one test case. Like
No, I mean the lower function now. Let's go back to the lower.
the lower function.
Yeah. What is the problem with this right now?
Well, it doesn't check if like the past value. Well, I'm guessing it doesn't allow for past value to be like digits.
It doesn't need to. So uppercase would probably handle that as it should.
Oh, okay. It does?
Yeah.
Actually, now I'm actually interested to know. Wait, can I just copy this over and just say 1, 2, 3, 4, 5 and 2, 3, 4.
I mean, we just ignore it basically. I think.
Oh, redefined here.
Because you used the same name for the second test.
Oh, okay. And
Because it uses that name to tell you which tests got failed.
okay, so it says.
But you forgot the test macro here.
Ah, okay.
Or
You have to
I
use
don't
that
know
every
what that's
time?
called. Yeah,
Interesting.
for every function. Because that's basically a macro, a procedural macro that generates some code for you.
Yeah, I see. Okay. Yeah, it passed both of them. Okay.
So
So
this,
if it's the digit, you would just ignore them, I guess.
So you see these tests and CFG
Yeah.
tests. These are procedural macros that generate some code. It takes these, like for example, when you make this a procedural macro on a function, that procedural macro that you have called, in this case it's test, it's gonna get the token stream, not just like C and C++ macros where like it just glorified text substitution, copy paste.
Yeah.
No, this actually takes the token stream from the compiler. And it does with it something like you could generate code, whatever, using the AST, etc. It can construct an AST, you can do all sorts of crazy stuff. And yeah, there you go, and you get what you want. So it's used a lot for a lot of things actually. It's used for reflection, it's used for cutting down on code. So probably this test actually does something, generates some code. Okay, so there's a tool in Cargo. Well, not Cargo, but like basically, crates.io where we have libraries when we can install libraries where you can say cargo add library, right? We can also there's also binaries in crates.io, right? There's some tools there, and one of those tools is called expand. So we can actually say cargo install cargo expand, I think, if I'm not mistaken. Cargo install cargo dash expand. Okay, right now we're just gonna go ahead, doloid that thing and compile that tool, and then I can use it however I want. Right, so this tool would hopefully help me see the expanding of that macro. I'm not sure if this would work with test, since test is kind of special, since it's provided by.
And your computer's dying because it's compiling and building these. I can barely hear you.
I see. Okay,
I
let's
think
wait
this
until
stream
it's
might be
done.
okay, but like the Discord voice, it's barely coming through.
I see, makes sense. That is wild. Okay, let's wait for it to compile. Okay, great. So you have compiled it.
Okay,
The
nice.
voice, I think, is back in a good
Oh,
shape
yeah,
right
it
now.
is back.
Great.
Yeah.
So I think right now we can say cargo expand. And hopefully we do the job. Let's see. Okay, great. Interesting. But it didn't expand the tests. It only expanded the other stuff. Interesting. Can you do it yourself? Because I think your terminal is kind of weird, right? When I'm doing it myself.
Yeah, it's a
So
little bit.
yeah, do
Yeah.
it. Say cargo expand.
Oh,
Right. And that's the code that would be generated without
I
macros.
see. Okay.
You see? So first of
see,
all, what do you
okay.
notice? The first thing that you notice.
Well, it gets a feature prelude import and then prelude import.
It basically
it's
imports.
prelude Rust.
Yeah, it imports some preludes, some stuff from the standard library.
Yeah.
Like you notice
Yeah.
how you can actually say some directly and none directly instead of saying option, std option. That's because of the prelude. The prelude contains some stuff that you would usually use like that. There's also extern create std. And what else have been expanded? Also the print line, look at that. That's what it got. It got expanded to a block with the stdio print, format args. Another another macro. I'm not sure if you can.
At the end of the like hello world, it puts a new line as well.
Yep.
That's interesting.
Help package lib expand only the specified. Oh, I think I can include tests. Yeah, dash tests. So say cargo expand dash tests. Oh, crap. Dash tests. With the S, with an S.
It needed to.
There you go. That's it.
Need to
that's
add the name of the test.
Just try this. And did it work? Yeah. It did. Look at that. So that's what got generated. The code that got generated through those macros. It's wild.
Oh wow. Yeah.
Otherwise you had to do all that code yourself. There you go. Now you have a tool in your toolbox. You just install it.
I'm guessing this is possible to be done automatically, like to call a function and then say create a test for me, because I don't know if you're if you worked with Java.
Yeah,
Java has something like that.
What do you mean exactly? Can you describe it more?
Like when you're using, for example, what is it called, the Java IDE that the company makes.
But like, what is it? How would you write it? Yeah.
So
C-line, JetBrains?
Yeah, JetBrains. Yeah.
Okay.
So essentially, you select the function and you just right-click, and you say create test.
But what it does?
Create test.
But how does it like?
It generates the template test for you.
I mean, yeah, you can make a VS Code snippet. You can make a VS Code snippet.
Okay, yeah. Okay.
I can actually make a VS Code snippet easily using an extension, and just use that. Though there may be actually a snippet here. There you go. Yeah. There is actually a
Oh,
snippet
okay.
called FN test. I'm not sure if you have it yourself. Do you have it? So
Let
try
me
to type FN. No, FN and
Oh yeah, this.
yeah,
Okay.
you do. Okay, there you go.
Okay.
There's
So
a
I
VS
just
Code
put, yeah.
snippet, right?
Yeah, nice.
You can actually make it easily yourself. There you go. Cool. Okay, so that's great. Now you can actually see the expanding of the macros in Rust.
Yeah.
So now let's go back to our lower function. What is
Okay.
the problems that you can see there? What's up with the strings? Is there any problem with those that we're using?
Well, I'm guessing it uses the copy function.
Well,
like,
I mean,
rather
it
than like
allocates in the heap, right?
Yeah.
So that's problematic because we don't
Yeah.
really need to allocate in the heap, at least first of all for the
Mhm.
arguments, right? And second
Yeah.
thing, what about the return type?
I mean, to be honest, for return type, like depending on the use case, you wouldn't like sometimes want to copy, but sometimes
Like, I
you
mean,
would
in
want to
this
copy.
case, yeah, why? Exactly
In,
why?
in this case, we don't really. Well, like I don't know. Let's say you are trying to like I don't know, get a bunch of files from like the system, and you know all of these files because you generated them. You have kind of named them in uppercase, and you ask the user for the file name, and they put it in, and you just turn it into uppercase. You don't really care to keep the old version, the lowercase version. You just want to like get the file. You don't care. You just turn it into uppercase and use like I don't know. At least in my like opinion, you just turn it
Okay,
with a
let's
pointer.
do
Just
another
change it in
test to make it
place.
more clear. Let's do another test to make
Okay.
it clear. So I'm gonna make another assert EQ here, right?
Okay.
And I'm actually going to have. And by the way, one thing that you didn't notice is you're using to uppercase, not to lowercase. Hello,
Yeah,
stars. Welcome to
why?
live stream. I mean, this is
Oh
lower.
yeah. Oh yeah. Oh wow. That's
So
funny. Okay.
you can say to lowercase. And let's fix this. But yeah, let's make another test that would actually fail, right? Well, not fail, but we would say NQ, I think? NE, I think NE, for not equal, right?
Yeah.
Because this shouldn't
Okay.
equal. So, Ramadan Mubarak stars, thank you. Okay, so this is good. Now, let's say this is like this, okay? So it's already lowercase. So what's the right value? Lowercase.
Oh, I see.
Isn't this the
Yeah.
same value as this?
Yeah, it is. So you're not checking, but it's. Well, Can I see? Okay, I can go into the like to lowercase function. I suppose they would check for this.
Yeah, well, like the thing is, you can have the same string,
Yeah.
but then you wouldn't have to actually create a new string. You can just return the original string.
Yeah, that's true.
That's
But
the
like,
thing.
yeah.
But yeah, let's just go into the implementation, and I think you'll understand. I just wanted to little bit flex in your brain right now.
Yeah.
Okay, so instead of string, you gotta go with the stir reference.
Yeah.
So we
so
don't want
use
to
stir
allocate a new string or take ownership of it. We just want to borrow it for a couple of nanoseconds, I guess. Right, in this function scope,
Yeah.
right? So great, and this actually would work just as before, no problem, right? Try the cargo
Yeah.
test real quick.
Test.
Oh, really?
One failed.
Oh, my bad. The EQ
Oh.
here should be EQ here. Okay, try.
Oh, okay.
Okay, great. So two
Yep.
passed. All right. So the next thing that I want to do here is I want to check if the name is already lowercase. If it's already lowercase, I don't want to allocate a new string.
Yeah.
So
Yeah.
what I could use there, I could use something
You could just
interesting in the
return
standard
the-
library. I would use a
Okay.
cow. Let the
Ow,
cow, you know. The copy on right, right?
Ah, okay.
So use std cow, I think. Try that.
STD?
Well, not here. Here, yeah.
Yeah.
Use first of all, so you can
Ah, use. Yeah.
std. I
STD.
think it's std cow, maybe, right?
No. Nope.
Hold
It's
on.
not cow.
Or we could just put a cow here, right? And then hopefully, there you go. Import std borrow. Yeah, it's
STD borrow.
import. Whoops. Let me try it. Import std. There you go.
Oh, okay.
Use
Yeah,
std
yeah, I see.
borrow cow.
STD borrow cow. Okay.
Okay,
Yeah.
so what is the error that we have here?
So it says missing generic for enum cow.
And honestly, before we go that path, you know what? Before we go that path, the first thing is that this two lowercase function that in the standard library actually gives us a string. So there's no way we can. So we have to actually implement it ourselves first, and that's actually a good exercise in itself too. So let's just go back for a second to string as we had before, and let's just do it. Try to do it without two lowercase. Try to do it somehow else.
String manipulation, interesting.
Yeah.
So
you need to construct a new string with all the characters lowercase. And do you remember iterators?
Oh yeah, we did do them.
But I didn't teach you a lot from the user side of iterators, though I taught you how to, or I taught you how to make a basic iterator.
How to make a
But you know, just try anything real quick that you can think about.
Oh, let's see. Name. Can I use this?
Try.
Can I use characters from the like? I just use for loop and
try it and compile and see what it tells you, right? So.
Let's say for in.
Char is a what is it called? A keyword, so you cannot use it as an identifier. I think. Use character. Let's call it character. I think. Okay.
Okay, so in... No, it wouldn't be this. I need the index. I can use this for loop. Let's see, for... Okay, index... Your name... Oh, what? Oh, okay. You're adding those from prefab.
Yeah.
So from index value, and it wouldn't be value. It would be. How can I get the name dot?
Well, this is not Python. If you need the index, you have to iterate through a range.
Yeah, but like I want to get the name's length. Then. Is that that thing?
Yeah.
Name.len expected.
But like, why not just iterate through the name directly and get the character?
Yeah, I can do that.
Okay.
Okay. Would I use the same for loop though?
Yeah, same for loop. There's no need for the index, you know.
There's no need for the index.
Yeah.
So you mean?
Oops.
Oh yeah,
I see.
Yeah, I missed it. Okay, so can I use this for loop and just iterate through it?
Just like normal character in.
What the?
Character.
What the hell?
Character. Chatter.
Character. Okay.
Character, yeah.
Oh my god. Okay, character in
name.
Let's see. But the character wouldn't give me the name
try. Just print line and compile, you know. The compiler is
Okay.
your best friend pretty much here.
Fine. Let's see what character tell it gives me. Nope, it doesn't even want to. Okay, it says expected
So
string
stir,
found.
I mean, it's
Right.
quite interesting. It's quite different from other like strings in general in Rust because of something that I'm gonna tell you about later on. So you cannot iterate through
Okay.
it directly. You know why?
Why?
So do you want to iterate through ASCII characters, or do you want to iterate through Unicode characters, or UTF-8 characters, or graphemes,
Well,
or that's
well,
why Rust doesn't allow you to iterate directly through the name. You have to explicitly say what you want to iterate through. So
doesn't it underlyingly have like a specific, like,
say name dot and try to
yeah?
find what you need. Name dot what?
Okay.
What do you want to
Name,
iterate through in the name?
Uh,
Literally what you want to iterate through.
ASCII
Chars,
okay.
chars.
Char. Yeah. Chars. Oh,
There you
okay.
go.
I
So
see.
now you get an iterator over the characters.
Okay. I see. Okay. So now
Daniel
it says that
Galano, welcome to live stream. What is Comcast?
it says
Where did you see Comcast? Okay.
so now it says that mismatch type. Expected string found.
You know, compile.
Object. Okay.
Oh, I see. And you know why? Because you need to, return the string, but you're not. So right now, to tell the compiler you're still working on it, you can make a to-do macro here.
Wait, really?
Yeah.
Huh. Interesting. Okay.
So it doesn't bother you.
Must be a string literal. Dot. Into. You figure it out yourself. I don't care. It doesn't. Okay. Huh. Very interesting. Okay. So it doesn't like the 2 into. Dot 2.
Format
String?
arguments must be a string literal.
Yeah.
You remember what print line needs first? It needs a format string first.
Oh yeah. Okay. This and then.
You could just use it directly there.
Yeah. Okay.
Okay, compile.
Let's see. Cargo.
Cargo
R.
test. Cargo
Oops.
test.
Cargo test.
Yeah. But I don't think print would. Oh yeah, it does work actually. Or does it? Hold on, no.
Okay, it does. Yeah.
What is it? Prints. Oh, there you go.
Yeah,
I
it does
see.
print. That's,
Yeah. Okay.
that's cool. Okay.
Oops. Okay, so you're iterating through the characters. Now, what you want to do? What you want to do first of all to the character itself?
So to the character.
See the methods
itself,
on the
you want-
character.
Hmm?
See the methods on the character. So dot.
Oh yeah. Dot. Let's see. As ASCII. Oh. Phone, clamp, phone.
Try to find lower maybe.
Oh, wouldn't lower just do the same thing as?
But no, it wouldn't lower a string. It would lower here a character, which is just a byte or whatever.
Lowercase.
There you go. So that what that returns? It actually returns iterator.
Oh.
You know why? Because if you read the documentation, it returns an iterator that yields the lowercase mapping of this char as one or more characters. Because like the lowercase, depending on the language and such, it could be multiple characters.
I see.
So this is an iterator. But you know what? Keep it simple and just say to ASCII lowercase, I think.
Yeah.
We don't care about Unicode here.
ASCII lowercase.
Okay, so that would give you just one character.
But this one says makes a copy of the value in its ASCII lowercase equivalent. Okay.
So yeah, go ahead now.
So now you just...
Okay, so what you want to do with this character? Where do you want to put it? Do you want to collect it into a string? So you gotta make a string here. A new string.
Yeah, true.
So let.
Oh, let. Yeah. Can I use a string instead of let?
But you need the let first to make a variable where you can push to the string.
So let lower name
Is
and
equal to,
well, do I need is equal to?
yeah, and string new
Oh, okay. Strange.
with the namespace, because that's new is a static function.
Yes.
There you go. Call it. Yeah. Now what you're gonna do to push that character into the string instead of print line? What you gonna do? You got the ASCII character, the lowercase
yeah.
character right now.
Well, let's just do it underneath the print. Let's say lower name, but append?
Push.
No.
Append
Push,
would
okay.
actually do multiple characters, like an iterator of characters. You would actually do character to ASCII lowercase.
Oh yeah, sure.
And you could just remove print line, and you need to make that mutable so you can push to it.
And this whole mutable thing,
Yeah.
that's actually kind of insane.
And now you need to return the result.
Now I just returned it lower.
Instead of to do.
Lower name.
Try run this without the semicolon so you can return it.
Oh yeah, sure. Yeah. Yes.
And it works.
Hey, it passed. Yeah.
But
nice.
there is a way to use iterators for this.
Okay.
So to start simple, you can actually say name.chars.forEach.
Oh, I see.
And then character.
Oh yeah.
And then you could do the same exact thing here.
Ah.
That's the first level, I guess. The second level that you can do here is map first. Map it to what? What you want to map the character to.
To the
Each character to what? To its?
Who's ASCII equivalent in
Exactly.
lowercase.
Exactly, that's what we want to do. And yeah, there you go. And so after we have mapped all those characters as an iterator to ASCII lowercase, we want to collect them into a string.
Yeah.
Or we can collect into that lower name.
Yeah.
I think I never used this one. Oh, I need the mutable reference here. But this is an unstable feature, so it's still being added to Rust. Either way, what you really want to do actually, instead of creating a new string like this, you would just collect that iterator. You remember, iterators doesn't actually allocate until you collect them or use them or whatever. So collect into a string. And there you go. Now you just return this, and you don't need this.
Oh, okay. So it already... Wait, so the collect, does it create a copy of the...
It actually just starts allocating. It creates a string and start pushing all those characters from the iterator. It consumes all the iterator and pushes those values into the new string.
When it reaches the end of the map, it will just push it back out of the function.
So other than this, how we can also make it nicer is maybe we can actually say char to ASCII lowercase directly here. Maybe not. I see. Can we make these references by ref? No? Well, that suck. Anyways, so we cannot do this since it's taking a reference and such. Whatever. Alright, so there you go.
Okay.
Great.
So now...
Isn't this more readable?
It is more readable, but what if we wanted to not create a new string and just make them lower in place in memory?
I mean, we can take a mutable string like this, right, and do it in place. But that's usually not the way you want to do it, right? That's a bad way to go about it idiomatically. That's what you would do in C, right?
Yeah, but
there is a better way.
No,
there is an efficient way using this method. So you can actually say cow, right? Copy on write,
Okay.
or actually it's a clone on write, but it's the same thing pretty much. Anyways, so here you actually need to give it two things. You need to give it a lifetime, which I haven't taught you yet, and it takes the type that we want to return, like like this. But now here, the thing is, we need to see first of all if it's already lowercase or not. So we gotta say if name dot is lowercase. So here, notice, well, is there no is lowercase? Interesting, there is not. Okay.
But you can get the chars and check the chars.
Yeah, we can use all. And all, what they should be, character. All characters should be, what?
Character that is lowercase, yeah.
There you go. You see how readable that is? You take the characters and all of them should be lowercase.
Nice, okay. Cool.
And if that's the case, we already have the correct string. We could just give it.
We will just return
without allocating it. We only need a new string when we actually want to change that. So we can say here cow borrow. Basically we're saying we're just borrowing we're returning the borrowed string. Else we're gonna return our new string. So we're gonna say cow owned. Because right now we're gonna create a new owned string, right? Which is basically allocated. Okay, so mismatched types, expected reference, cow, found reference, let's recompile and see what's up. Hold on a second, oh, what? Why do we have this borrow function here? Oh, I see. Borrowed. Okay. Name. Alright.
Okay, so what is borrowed and what is owned?
Borrowed meaning that we're not allocating a new string. We're just giving you back the reference that we got.
Okay. We are borrowing what you just gave us and we're returning it back to you.
Yeah, exactly. It's not allocated. It's not a new thing, right? Because if the string is already, perfectly, we don't need to mutate it. Why create a new string? You see?
Okay.
But if it is not lowercase, then we actually need to mutate it. So we have to actually make a new string, right? Otherwise, how are we going to do this?
Well, is it possible to do it without creating a new string? Like, instead of, like, because I'm guessing, like, if we actually kind of...
I mean, yeah, we can use that. We can use the, lower in place, but you'd have to create a new function for that, right? So that's a different thing. You would say mute string, s, and you would do that, etc. Right? So that's.
And what would be the return type? Oh, you wouldn't have a return type.
You wouldn't have a return type, right?
Yeah, because you're just changing it in place. Okay.
Yeah. So,
okay.
I mean, we could go try to implement this one.
Oh,
So this would be in place. So you have a mutable reference to a string.
Yeah. Well, first of all, just put that first if statement that we have.
But you don't actually need it in this case, since you don't need to borrow or own. You're just going to be editing the characters in place. So you need to iterate through all the characters with a mutable reference.
I see.
So for...
So can I just say, let's say for...
Though I'm not sure if you can actually do that, since Rust strings aren't like just ASCII strings. They're more...
that's what I was thinking.
So I'm not sure, because I never really done that. I would just do it like this, honestly. But yeah, try. Let's go with it, I guess. For... character... in...
Let's say go with char. I don't want to type that much. In name.
Char. You're Chinese?
Wait, it was S.
S dot. I'm actually trying to learn some Chinese right now. It's a lot of cha-cha.
Yeah, I'm learning it as well. So, find S in chars, and then what we would do, we would say that
But well, hold on. This would actually give you an iterator over, copies of those characters, right? But you need a mutable
Oh, I
access
see.
to that string. I actually never done this before myself because I would honestly not go that path. Interesting.
I mean, you've done like game development and stuff. Like,
Yeah.
it would be much more efficient
Like
to just.
even actually, this is like efficient enough. Like in Godot, they also use a lot of copy on write stuff. They don't use the standard library of C++. They have their own
Okay.
data structures that use copy on write, that abuses copy on write. So let's see. Right, let's try into this right attorney. Whether the yeah, you would rather probably avoid this altogether.
Yeah, because Russ is gonna
I
make your
don't
life
know,
difficult,
like
obviously.
because strings, they're not that easy as C ASCII strings.
Yeah,
They're
I
more
see.
advanced than that. But I mean, let's see. Rust mutating string in place. Because I never actually even tried to do this before for strings. It did string in place with a function. I mean, they're just making a new string, so that defeats the whole point.
Yeah, that exactly.
That was even that is not even an option. So
Yeah,
I don't think you can actually do that.
I see. Yeah, maybe there's some safeguards around that to not let you do that.
Though Rust would always have some unsafe functions that you can use to do all sorts of performance stuff.
Yeah.
Just give me the pointer.
Yeah.
Yeah, I don't see a solution here, so I don't think that's gonna be easy because Rust strings aren't, ASCII strings; they're Unicode
Yeah.
and such. So, but yeah, either way, I think
Anyway,
this is
doesn't
way more readable,
Yeah.
way nicer, I guess. The nice
Yeah,
thing
and
about
also
in place, is that you don't have to check if it's lowercase already or not. You would just loop through all of them and make them lowercase. That's as simple as that. But yeah, this is how you would do. Though one thing to note is that a cow isn't free, right? Nothing is free because you have the lower head of checking if the string is actually already lowercase or not. So this is a linear. So yeah.
Yeah.
And since this takes self instead of reference self, you could also, instead of doing this, creating a new closure, you could just use char is lowercase. There you go.
Okay. Well, I was also thinking, like, wouldn't it be kind of more efficient to check one by one, character by character, and if it's not lowercase, make it lowercase, and just like when you reach the end of the string, just return it.
But no, that's what's in place string there. That's not possible. We cannot mutate this name.
I see. Okay.
And even if we made it mute, then you cannot use, let's say, first of all, you cannot actually mutate it in place as you've seen before, because it's a Unicode and such. You probably have to use some more advanced stuff.
Yeah, I have to get out of the C++ mindset. Yeah.
That's first thing. And second thing, this could be like you wouldn't be able to use literal strings anymore with this function. So you see just a lot of problems. So this is the best way I think to go about it, in my opinion.
Okay.
And I think you probably don't need to say the string exactly.
Okay.
You can just tell
because it will just
the
figure it out.
yeah. And there you go. That's pretty cool. So
Nice. Yeah. That cow is interesting.
maybe you could even make it more functional.
Oh dear.
Yeah, I love
language dimension.
functional, but I'm not that crazy for hacks. Sorry, not hacks. What is it called? Haskell.
Yeah. I did like a module in Haskell at university, and that was like they gave us an option. Do you want to do an easy module or do you want to do a difficult module, which is Haskell? And I was like, I'm up for a challenge. And then halfway through, like halfway through the course, I was like, I hate myself. I hate myself. Oh my god. But to be honest, it was fun. It was fun
Yeah.
because I did put in the work and I got like one of the highest marks. So it was fun to do.
Yeah, disclosure with
Yeah.
no arguments. I see.
Unwrap or else.
There you go. That's the whole functional thing right now.
Oh my god.
So,
Like you see, those kind of things breaks my brain. Like
but this is very readable, at least in my opinion. So you iterate through all the characters in the
Yeah.
string. You check if all of them are lowercase. Then, if it is
they're not,
lowercase, then some cow borrowed. Otherwise, get a co-owned. There you go.
I see. Okay.
It's declarative, you know.
Yeah. This is just putting all of those code in just one line. That's
Exactly.
all it does.
Exactly.
Interesting.
Try it though. Does it work or not? Because we didn't try
I
it.
don't know. Oh no, not run test.
I mean, it's beautiful, but does it work?
Yeah, it does pass. Yeah,
Okay, cool.
it does pass. Nice.
All right. So should we go to some generics? I think. Yeah.
Okay, let's go generics.
Okay. So what is the difference in short? What is the difference between stir reference and string?
Stir reference and string? What do you mean? Like one of them is a reference to a like pointer to a string. The other one is a like object.
Yeah, it's an
Is that what
allocation,
you mean?
right?
Yeah, yeah.
And what we use
Yeah.
cow for?
Well, we use cow so that if it is like already the thing that we are passing in that we want,
Yeah.
we don't like mutate it or like we don't change anything. We just pass that out.
Yeah, we don't
as
need to allocate a
borrowing
new
it.
string again and so on.
Yeah.
Yep, pretty
We
much.
just borrow it, and if it is like something else and we want to change it, we own it and then we change it and then we return it.
Yeah, the only catch with this method, what is it? What is the overhead here? That you have to be...
Well, the only overhead is when you have to pass it in to check if it is lowercase or
Yeah,
not.
so you have the overhead of
Yeah.
checking if it is lowercase or
Yeah.
not. So this is kind of
all
your trade-off here. So like if your strengths will be like most of the time, like a big percentage, they're gonna be the same. They don't need change. Then this worth it, absolutely. But otherwise, maybe you just want a simple to lowercase, right? Without
Yeah,
all this mess, right? So it depends on the probability there, I guess. But
Yeah.
All right, cool. Cool. Okay, so I think let's go with some generics right now. What do you think?
Okay.
Generics are crazy in Rust.
Do it.
Okay, cool. So what you're gonna do, you're gonna create a matrix struct,
Okay.
generic matrix. Then we're gonna
Oh,
start
Jesus.
with a concrete type of matrix. Then we're gonna up the game basically.
Okay.
All right, let's go. Struct.
Struct. Let's see. Struct.
Other than iterators, by the way, hold on. Can I go back real quick? Something I wanted to tell you before that. Notice here in wrap or else, right? Notice that here, instead of passing the thing directly, I'm actually making a closure. Because instead of...
Okay, yeah.
Because there is in wrap or, I could have used in wrap or and just passed this directly, right? But I used or else to make a closure here. Why, in your opinion, that's the case? But I didn't do it here.
Interesting. I don't know what closures are for, to be honest. That's why I wouldn't be able to.
So closures is
you
what you can call, you know, they're lazy. Because,
okay.
because the thing is, then some here, this is eager. So whether this
I
is the
see.
case or not, it would construct. Before even calling this sum, it would construct this co-borrowed. But this doesn't matter, it's just an enum, so it's not a big deal.
Yeah.
So I didn't bother to go ahead and say then some, like then you know, I didn't choose the variant that you pass in the closure, right?
Yeah, yeah.
But here I did because construction this is a big deal, right? You don't want to construct this without, because closures are lazy. You only call this when you actually want to call it, right? It's not like arguments which are eager. They get you know, they get evaluated before even calling the function. You see?
Yeah, I see. I see.
That's just something I wanted to point out.
That is interesting, to be honest.
Okay, great. Alright, so yeah, we can just remove this stuff now. Alright, so can you create a struct matrix now?
Okay, struct matrix. Struct. What am I calling it? What are we doing? Generics again?
Nah, just say matrix. Just call it matrix with the big M.
The
matrix, right?
Okay, the matrix.
Open it up.
So
okay, so what we're gonna have here? Well, instead of using the struct, actually, we could just use a kind of like a tuple syntax. And here, so what a matrix? We're gonna go with the static matrix, meaning that its size would be defined at compile time. So we're gonna use an array for it.
Okay.
So let's start first of all with the little vector. Let's say this is a vector. So what we're gonna have here? Let's make an array here. I declare an array here.
For like, I know how to make it.
Nah, just declare it. So like this, and then the type here. The type, just say something like F64 for now. Let's start with concrete. Always start with the concrete, then generalize. So it's easier that way.
64 and...
Here how much, let's say made a vector of 3 dimensions.
3, okay.
Is it the other way around? I've just taught Zig last night, so maybe I've...
It's not the other way around, I remember it was that.
Maybe it's the other way around. Huh? Hold on, cargo R. Expected type, well, that was right. Oh, yeah, my bad, semicolon here. Okay. There you go. So, I mean, we could have made a struct. Could have made a struct like this.
Yeah.
Components, let's say, then do it like this, right?
Yeah.
But I didn't bother to because this is kind of like a wrapper over an array, so no big deal. No need to name a whole field for it. You know, just use a tuple. Okay, great. Yeah. So first of all, try to construct a vector here. Construct A vector and B vector.
A vector and B vector. So let's say.
Yeah, honestly, I think a matrix would be quite hard for you. So let's just go to vector anyways. A equal to, well, you say let, it's not C++.
Oh yeah, sorry.
Let A is equal to some vector. And no, we don't have new here. You just call it like a function. And you pass in an array.
That's an array. Empty array.
Yeah.
Is that possible?
And some floats? No, it's should be 3. You know, the length is a compile time. Should be 3 values here. There you go. Cool.
Cool.
Okay, try to print this. Try to print this.
Okay, let's see.
And you could just put it here. You could just call it here.
Oh yeah, true.
In the semicolons. Control S.
What is it saying? It says vector doesn't implement display.
But we can make use of a debug printer by doing this, right?
Yeah.
But then what happens there? What it says?
What cargo says.
But what is the error first, yeah? What is the error?
What is the error? This
Vector?
vector doesn't implement debug. God damn it. I
Because
drive
you have to
debug
implement
to
a
manually.
debug and implementation for it
Oh
first.
dear.
So what is the solution that Cargo gave you, or the compiler gave you?
So just put this here.
What is this again?
Then
What is this syntax? Does it remind you of something we've
it's
seen?
what was it called?
Procedural?
Yeah, macro.
Exactly. So what does
Yeah,
that
macro.
does? It generates some code for you.
And yeah.
Generates a debug formatter.
Okay.
You can use cargo expand and see what it returns, what it generates. Cargo expand. Look at that. That's the code it generates for you.
Oh damn. Okay.
Impl, core FMT debug for vector, inline fn fmt.
Well, if it could generate this for me, why did it give me an error? Just do it, or
No, like it doesn't want to do, an unnecessary overhead. You only get what you pay for,
I see.
So,
Okay, interesting.
Because this
Let's
generates
see,
code,
Yeah. So yeah,
So this is the debug implementation, right? You can implement a formatter yourself to do however you want.
So the formatter gets a reference of self f and then mutate formatter.
But yeah, let's go to the next section. You can make a little does it necessary? I mean, yeah, let's go with it. Why not? Impl, so impl block. Impl vector, yeah.
Is it for vector or just vector?
Vector, yeah, just impl, yeah. And now FNU, right? The idiomatic constructor. What you would take here? You take an array of components.
Take an array, yeah.
Components. Well, I mean, it's a function.
Oh yeah, sorry. Components. Oh. Components. Oh, what components are we taking in?
It should be like this, and then what is the type here that you're gonna take? An array.
Would be
like this.
Yeah, an array. Yeah.
Yeah, F64, F64.
F64. 3.
Okay, and what you would return from this function?
So we will return a string, I'm guessing.
Why a string? A vector. We're creating a new vector.
Oh, aren't we? Oh, we are not implementing a debug format.
No,
I thought we were implementing
we're not. I see now why you're confused.
Oh, damn. Okay, so...
Vector.
A vector, okay.
What you can do other than vector here, there's another way to do this.
Chris?
Instead of vector, there's an alias
for
self. Exactly.
Is it? Yeah, self.
There you go.
Is it a small self or big self?
Big self, of course, because it's a type.
Okay.
Naming convention. Block. There you go.
There we go.
Now you would just construct a new vector, just like you have done here, pretty much.
Yeah, okay. Vector, and just let's copy that actually.
Of course, the array would be like copied over. Remove the semicolon here. And
okay.
And here you would pass what?
We would pass the components.
Exactly. There you go. Now instead of this, you could also say vector new if you prefer, pretty much.
Yeah.
Though in this case it's kind of an overkill, but you got the point.
Or then self and then vector components.
Great.
Okay. Cool. Okay.
Alright, so shall we try to make this a little bit generic right now? So, okay, cool.
So let's say we want to pass in any type of...
Exactly, yeah. So you would put a angle brackets here. Here where I'm putting my cursor. So you would put angle brackets. and then you would define your type there, t, let's say, or let's
Yeah.
call it scalar
Oh, okay. Yeah.
with a big S, since it's a type.
Mhm.
There you go. Yeah,
But
put
now-
it there, right?
Scalar.type.
No, just scalar. It's the actual
okay.
type. There you
Oh
go.
yeah, true.
But
It
now
itself is a
we
type.
have some problems, so use your compiler right now to help you.
Mhm.
Go with the refactoring. Okay, so what the
This
compiler
function
said.
associated. So whoa. Okay, at the top it says missing generic for struct vector, impl vector, expected one generic argument, scalar. Okay, vector, scalar. Okay, so just impl scalar. And then scalar.
Okay, what's the problem now? Run again. Cargo compile.
Yes.
Cargo run.
So cannot find the type scalar in the scope. Wait, no. Higher.
Okay, and
Oh my
what's
God,
it
what is
said?
You might be missing a type parameter. Okay, cannot find. Then it says function associated with item new is not found in the struct. Okay, so I'm guessing it needs to know what the type is.
So you need to
when we
declare
go
the type
inside
because
the
you're
impl.
passing in a type here, but that
Yeah.
type isn't declared,
Yeah.
so you need to declare it here too.
Oh,
Because the
I
one you
see.
declared here is only visible here in this scope right here. So you
Yeah,
need to
that's
declare
true.
for every impl block again to use it.
Okay. And how would you declare it? Is it just
Yeah,
same?
just like the compiler
Like
said
that?
to you, it
Okay.
actually told you the exact solution.
So if I put T, can I just put T here?
Yeah,
and
you
T
can.
here.
Yeah,
Okay.
that would work
nice.
just fine as long as you pass in the
Hey.
same. There you go.
I see. So the vector gets a scalar and passes the scalar to the array, and then impl block just gets a scalar and then creates a vector of. I see. Okay. Yeah, got it. Makes sense now.
Great.
Cool.
Now, what about making the number generic? Of course, this
the
should be a
number
compile
generic.
time since this is an array, so it's gotta be a generic. So we gotta put
Yeah,
it
that
here,
would be just
declare it
like-
first.
Say n.
Let's call it length, comma length,
Okay.
big L. Or actually, it should, since it's a constant, make it a couple case. Right?
That's okay.
Exactly. There you go. And declare it here, of
Okay.
course.
Yeah.
Comma length.
Bang. And then here have to be length.
But first of all, what's the problem that it said here in the start here?
Oh yeah, wait. It says is never used consider removing length. Oh,
Compile. Remove
So-
the change that you have just done right now.
Oh, yeah.
Only the change. There you go. Now compile and see what it tells you.
let me clear the first and then run it because it has a lot of stuff. Oh wow, okay. This is find this type parameter, not a value. Interesting. So it's expected value found.
It's
type
thinking that
parameter.
it's a type, but what we want here, we want to use size, right? So
Yeah.
we gotta actually tell it. Yeah, exactly. There you go. Look, go
I
ahead.
see.
Make it a U size.
You.
Because
16,
otherwise it would.
let's
No, it should be U size because you're passing it to an array
Oh, you
length.
Okay.
You gotta be expected.
Rate. Found built in.
Is it like this? Hold on. I don't think so. No, of course not. What the heck? Did I just forget how to do it? Hold on. Rust template constant. Or generic parameters. Hold on. Oh, my bad. You need the const here. You need the const. Here.
Okay.
Oops. There you go.
Okay, cool.
Okay.
So constant length of type U size, and then you pass in the size
Yeah.
length.
So this is a type and this is a constant. in compile time.
Mm-hmm. Okay, so now here I should be able to just pass in length.
Yeah, so you declare it, and then
Pass
and
it
where you gotta
here,
pass it, yeah.
here as
Great.
well. Okay, so it says expected value. Oh wait, I have to do const again here.
Not there. You're not declaring it there. You're actually using it there. Where you're declaring it? You're declaring it here.
Ah, I see. Okay, yeah, true. Const length of type size. Okay, cool. I see.
So try to make sure this compiles.
Yep,
Great.
it does. Okay, cool. Actually, this seems. I might actually eat my words later, but this seems easier than what I remember from C++.
Actually, in fact, I would have
difficult.
expected you to say this is more difficult than C++, but like this way of doing it is actually way better when you go to complex stuff. But right now you wouldn't understand why you have to declare the type again and such, and we have to declare it here and there, but later on you'll understand why.
Yeah, I kind of understand why you have to do it twice. Because like first time, like it's an implementation of what the vector is. So it needs to have everything ready to be able to make the vector. And because the vector takes in a scalar and a length, so you just pass in those.
No, you wouldn't understand right now until we get traits into
okay.
the picture and more complex stuff, pretty much. Okay, so great. Now, can you actually index into this vector? I mean, you should be able to index into it, right? So we're gonna remove this, and we're gonna put it here, right? Comma.
Yeah. So it would be comma 8. Wait. 8 dot.
Not a dot. Just like an array, you know, just like an array.
Oh.
I mean, yeah. Yeah, sure. Go ahead. Do that way.
Yeah. Wait. It didn't.
Save. Make sure to save.
It is saved. Wait. I think it's because of these two. Is it?
No.
No, it is not. Okay.
Just save and run. There you go. So what it gives you? The array. So that's good.
Array,
the tuple. And now try to index into it. Try to index into that array. Yeah, fine. Just into that array. Dot 0 and. But yeah, okay. Cargo run. And see what the compiler tells you.
This cannot index into value of type vector float 3. For more information, try Rust C explain E0608. Okay. Jesus, what the hell is that?
Why didn't it give you a more interesting error? Weird.
Explain, please. Let's see what it says. It says doesn't implement. Oh, okay. Vector doesn't implement index.
There you go.
I see.
So what we need to do right now to allow our vector to do this?
We just have to implement
the index trait,
or do we need a macro?
No, we don't need any. In fact, I never wrote a macro in Rust myself.
I see.
So you just implement stdop's index for that vector. So try.
That's easy to say. Try.
Impl. Let's start with impl.
Oh yeah, impl. And it would be std, right?
No, you would impl stdops index for the vector. So write stdops or just index and import index. Impl index. Right. And hold on. Yeah, for what?
For vector.
Yep. For vector. You would copy the generic declaration and such.
Then const.
Just copy those. You don't wanna keep on typing them.
Yeah.
You need to declare them. In fact, you pasted it in the wrong place. That's the declaration.
Wait, Oh yeah. It would be.
It would be here
import.
after the impl, yeah?
Yeah.
And
There
then
we
you
go.
would just copy this values. There you go.
There we
Great.
go.
Now
So
compile
now
and
it's
see
this.
what's up with the compiler.
Okay.
Okay.
So it says cannot find trait index in this scope. Import index for vector not found in the scope. Consider importing one of these items. Use core ops index or std. Okay.
Just use
I'm guessing
std ops
we need
index.
std.
Yeah. Use.
Okay.
Right, use. Exactly, and semicolon. Okay, try to compile now.
Oh dear.
You see how the compiler tells you exactly what you need to do?
Yeah. It says pop trait index idx. Well, okay. I see. So I need a
IDX. But what's the IDX? So go to the trait, like control click on that index and go to the declaration.
Okay.
And see if you
So
can figure out
IDX
the
of-
IDX.
oh.
What is it?
Is it trait sized?
But no, look
Okay.
into the whole thing and see if you can figure out what is IDX.
IDX. FN index, self index.
So this
Oh,
this is the function you're going to declare
Yeah.
to implement this trait, this interface.
Yeah.
And you have an index argument, right? And what the type of the index?
Well, the type of index is IDX.
You
And
see,
IDX is of type.
is a
What is
generic.
question mark sized?
Just ignore that
I
for now.
see.
But
So it's.
what you gotta pass now here? You gotta pass the type of the index. So just say usize. No, without the IDX, just directly, just like what you would do with generics, yeah, because it's actually generic there. Okay, and now let me just generate for you that missing members. Okay, so first of all, we got the type output. Cargo R if you need help.
Okay, it says provide the definition for the type equal type.
This is an associated type.
Output.
What is the output of the indexing? What is the output type of the index?
Well, it would be of the type that the T essentially.
Equal to?
So equal to
T. No, that's just to tell you that you need to replace.
Oh, I see. Okay.
Okay. And
Type output would be T, and then.
Okay, and what you need to do here instead of to do?
So it says fn index self index usize to self output, and here we will just need to get the vector.
So if you want to resolve this, what this would be? So reference of T, right?
Yeah.
So go ahead. Oops. There you go.
So that would be vector.
So how would you index into the value in that index for the vector? You gotta implement it here. What you have done before. You gotta, access the tuple, your array, your internal array. So how would you do that? Self dot?
Oh yeah, so it would be self dot
0.
Really?
Yeah.
0?
Yep. But without the semicolon.
Yeah, because we're returning it.
Without, yeah.
Where are you? Oh.
Control S
it's
and cargo
your cursor.
What is the other problem now?
That mismatch type. Expected reference T found T. Oh, I see. Okay.
So what you gotta do
because
here?
It's returning the entire thing.
It's return a reference to that thing, right? So what you gotta do here?
Yeah. So just reference it?
Exactly. Control S. But here you're referencing the actual array, not the array
Yeah.
at index, like the value at index in that
Yeah.
array. So what you gotta do here? You gotta index
So
into
would
it.
be
No,
start-
dot zero, and then
Oh,
you would
okay, I
index
see.
into the array.
And then
Okay.
index
So what is the
into
index
array.
in this case? It's index
The
of
index
argument
would
that
be
you
index, yeah.
Control X and try
Ah.
this. There you go.
Ah, wait, you gotta give me a moment to understand this. Because, whoa, what the hell did I just do? Okay, so impl t constant usize and then
This is quite
index
advanced, by the way. So
usize for vector and then type output t. I understand up to this point. Okay. Then we say fn index takes a self and takes an index and then returns a reference to the self of type t. Okay, that all makes sense. So far makes sense. So reference to self dot zero. What is dot zero? That's what I don't get.
well, what is a vector?
Oh, a
Look up there.
vector
Look up
is
there.
an array, yeah.
It's a tuple of that is
Yeah.
inside of it is an array,
Of type
and the
then
array
a
as
length.
it's what index in that tuple? 0.
Yeah,
So
I see. I see dot zero. And then
we index
dot
into
zero
it.
and then index into it. Ah,
Right.
interesting. Interesting.
You see?
Wow, okay. Okay.
So
yeah,
operator overload, then it's just interface, implementing an interface called index.
I see. So now I'm guessing here I would just say index and then put 0. Right? I can do that. Yeah, and then if I
Yeah, you can also do that, sure.
Oops, wait.
So that is just syntactic sugar, right?
Oops. Okay. Cool.
But the problem is,
Wait.
try to use this now to mutate the vector. Try to use the indexing to mutate the vector here. Try to change the second value to something else in the
Or
vector.
it wouldn't allow me because it's not mutable.
Exactly. So try it. Try and see what the compiler said.
You wanna throw me in the pit. Let's say add 1 is equal.
Because I'm really emphasizing working with the compiler. Like, it is pretty much the best.
Yeah. So it says cannot mutate. Okay.
Okay,
we'll
cargo
mute-
R. Cargo
mute-
R.
mute.
Yeah, exactly. Cool. Now
Let's
cargo
mute
R
it.
to get more information.
Says cannot assign data in an index of this. Help. Trait index mute is required to modify indexed constant. But it's not implemented. Oh. So I need to implement a new one?
Yeah, called index mute.
Ah.
So just copy that.
Copy the entire impl?
Exactly.
Or
Impl,
I see.
right? And then paste it and change index to index mute.
index.
Mute. Or the mutable
And then-
version. And then what the reference here should be.
Reference. Wait.
Mutable.
The reference. Mute. Oh, yeah, sure. Sure.
Mute
not space,
space, yeah.
mute.
And here too. So you're gonna get mutable access to self too. And same thing here again.
Okay.
It's that simple.
Wait.
Cannot.
It says cannot find trait in this scope.
Let me import it.
Let me.
There you go.
I was
But it's
thinking
not.
that's
So
probably-
okay, now cargo R. There is a little problem here, but cargo R.
Or oh wow, jeez. Okay. Type not a member trait index mute. What does that mean? Not a member of trait index.
It's not part of
mute.
the contract of the. It's not part of the interface, so you don't need it.
Ah, I see. Okay. So we can do this.
And in
Okay,
fact,
okay.
this should be called index mute. Yeah.
Oh yeah, true.
No,
Oh, underscore. Yeah,
exactly.
because the function. Oh man, this this actually this is annoying in Rust. The fact that it forces you to name things in a specific way. It's like, just let me do whatever I want. It's
Well,
like,
it
you're
didn't
not
go
my
so well
dad.
for C++, so we're not doing that.
I mean, Windows is written in C++. Thank you.
Cargo R?
Whenever we have Windows or Linux entirety is written in Rust,
I mean, it's
then we
all
can have
flowers for the user. It's all about the
yeah,
developer. It's a L for the
yeah,
developer.
yeah,
But the users only see flowers, pretty much. It's
yeah,
made in
true.
C.
Oh. Okay, cool. Okay.
Alright,
So
but why we
this
didn't
is
actually declare
manual.
this out, this associated type here too? And why we did need the associated type in the first place? Isn't this kind of weird?
Self output.
You see this output associate?
Yeah. I think what I would guess is that because when we are changing something, it will be able to infer the type from what we are trying to mutate with. And when, however, it wants to give us back an index, it needs to know what type it's going to return.
Yeah,
Is
but
that right?
you could have just said mutable and t, here. It doesn't really
Yeah,
matter. But the nice thing about this associated type is that notice that it's being used here too,
I see. Okay.
right? So
Yeah.
what's this allowing us to do is it's gonna make sure that you cannot change the type from mutable. So index and index mute should have the same would have the same output as always. There's no way to go
I
about it.
see. Okay.
Index mute, if you check it out, control and click on it, it actually is inheriting index trait to inherit the output associated type
I see.
with the same
So
IDX.
you cannot import index mute without implementing index first. Then
Yeah,
I see.
and
Okay.
it have to be the same type. It cannot be a different type
See.
because it doesn't make much
Okay.
sense.
Yeah. Because it inherits from that, it doesn't really need that like explicitly because
Yeah.
it already has access to that. Okay.
Did I actually explain to you slices in Rust?
I don't think so. No.
Okay, so let's do just a little run here. So let's say let idk. Let's say an array, right?
Mm-hmm.
And let's say we have a function. Yeah, right. So write a function that would basically take an array and would sum it up. Sum.
Sum it up.
Yeah. Call it sum.
Mm-hmm.
Right. It would take an array.
Take an array of.
Well, you should
are we
call the
doing
argument
generics?
first. No, without generics. This is just to give you a problem first, then give you the solution.
So what does it return?
Well, first of all, what it takes.
Let's say array. No, array is
Or numbers. Let's say numbers. Numbers, and then the type is an array. Just like we've done before. And just, make it for this one. No need for generics right
So it
now.
would be U16.
U32 by default. If you didn't specify the type. Yeah, there you go.
No,
And 3. Say
That's-
3. Just say 3 because we
right.
have a 3 here. Okay, cool.
Okay.
Now what this would return after we
Well,
sum.
oh yeah. After sum, I'm guessing you will return just the U32 again.
Yeah.
Oh.
And what you would return here. So try it out.
I'll just say to do. There we go. So that doesn't give me error for now.
Okay.
So I'm trying to get every single one of these and then add them up. So I can just use the index, can't I?
Can
So
you
I
try to
can
use
say
iterators instead?
that. Oh yeah. Oof.
We'll see if it's already built in, first of all.
Oh yeah, sure.
So numbers?
Numbers. Dot add? No.
No, that's sum.
Sum. Okay.
Yeah, it's that simple. Yeah,
Wait, there's no dot sum.
really?
Yeah.
You
There's a
gotta
split
iterator.
view.
You gotta make it into an iterator first. So you gotta say into iter, dot into iter, because it's an array. Because sum is actually implemented on iterators, right?
Sum. Yeah. Okay. Wait.
Now
Is that it?
remove the to do. Try to use it. Print line.
No way.
Or actually, instead of print line, since we're just debugging, there is an easier way of doing it, which is dbj. dbj macro. Oops, hold on.
Yeah.
Go do it, yeah.
Okay.
Okay, just do it. dbj macro.
J.
No, J,
DBG.
like debugging.
Oh,
Yeah, exactly.
Yeah,
And just say sum s,
Sum.
array s.
Yes.
Or you could just inline it even, but yeah, okay.
Okay, so sum s is equal to 6. Yep, that's correct. So numbers.iter.sum. Okay,
Alright,
nice.
great,
Yeah.
that's great. But let's see,
Sure.
create a vector with 3 elements now.
Create a vector with 3 elements.
Yeah. Let's
Let's...
call it something.
Are we making it mutable?
No.
Okay. 3.
Just like this array, but vector instead. You
Yeah.
cannot start with a digit in an identifier.
Oh yeah, I see. 3 number. Are you going to? I swear to God, fit that. What is the name now? Okay, so
No. I mean the vec. The Rust
what?
vec.
Sorry?
The Rust vec. The Rust vector, not our vector.
Oh, okay.
Vec. The big V.
Vec, and what is it? Just open bracket.
No, new. New.
New.
Or actually, since you want to initialize it in place, you use the vec macro. Vec macro. There you go.
Oh, I see.
Now just
okay. Yeah.
do the same exact
One.
thing, right?
Three.
Semicolon.
Oh my God, snake case. Shut up. Swear to God.
Okay, so dbj and do the same
Some
thing.
3 numbers.
No, keep that one. Do it.
Nice.
Do another one. Yeah. Oh.
Oops. What the?
Okay.
Uh,
Print the new one.
the number. Oh, okay.
Okay, so
it
what's
says
the problem
expected
there?
array 32 bound struct vector integer.
So here we have a problem. What's that
wait.
problem?
Wait,
No,
I
you
wanna
cannot
try
actually
this.
fix it like that. You cannot.
Why not?
So you see the problem now?
Yeah,
What is the
I
problem
see.
that we have here?
Well, because I'm guessing the implementation of the vector.
No, what is the problem? We have a problem here.
Oh yeah, it's
Why?
not generic.
Not about generics. Just tell me just the problem that you see here. Is the fact that
Well-
we cannot accept.
We cannot accept a vector because we are expecting an array of U32.
And if we
vector.
change that to vec, then we cannot accept array.
Exactly, yeah.
So we need some way to actually be able to accept both at the same time. Doesn't
Okay.
Not even both. Anything that is contiguous space,
Okay.
like contiguous memory, right? So we can
Yeah.
actually use a slice here,
Ah,
right? So instead of
there's something
an
called
array,
slice.
yeah, it's even in C++. It's called view in C++, like string
Oh, yeah,
view.
yeah.
So if you
Yes.
do it like this, now it's a slice, and the length is actually runtime.
Ah,
So this is a slice. So you don't care which
Okay.
what backing that memory
I'm
up.
just saying it's a.
You just
yeah,
want
it's a
a
reference
contiguous,
that
yeah,
starts-
you want
yeah.
a contiguous amount of stuff there.
And you have to give it the type so that it splits it for the exact amount of
Yeah.
memory location and
So,
then finds the next.
all right, but we have a problem. Both right now aren't accepted, so we gotta reference them up to be able to get a
I see.
slice, and then we're gonna get a slice of the whole thing.
I see. Okay.
But what if we only want a slice of, let's say, the only two, like the two first things, then we can do this.
I don't think it would care. Yeah, it should work as well.
Yeah, so we would take only the two numbers, the first two numbers here.
Okay. Cool.
You see?
Ah. Yeah, that's actually very interesting, this thing. That you can just get a reference.
It's crazy how a lot of programmers doesn't know about that, because like the moment
Yeah.
I've learned about that, like
That makes it so
because
much
basically
easier.
here you're saying that you don't care about what backing that memory up. I don't care. I'm not owning that memory. Just
Yeah.
and I don't care what data structure it is. As long as it's contiguous memory, give it to me. That's
see.
how it goes. And I don't care if it's compile time length, runtime length. I don't care. Just give me a slice,
Yeah.
and I'll
I
do
see.
something
Okay.
with it. Okay.
Cool.
Alright, so that's what a slice is. And you see this? Without this,
Yeah.
you're just gonna take the whole slice, pretty much.
Take
if you
the
just
whole
do
slice,
this.
yeah. I'm guessing for this as well, right? Or would it
Yeah,
not
you can
work
also
for this?
you can also do it there, yeah.
Okay.
We would slice to the vector. There
See.
you go.
Yeah, cool.
Okay. Alright, so next up, what if we actually have a range instead? So try to do
Range.
another DBJ, right? Sum.
Huh?
DBJ here.
DBJ. DBJ.
Sum.
What am I passing in?
And let's say you want to pass in a range, yeah? Do 0 to, well, 1, 2, 3
Oh, yeah.
in this case. 1, 2, 3. 1,
one.
range 3, right? Without the array, this is just a range.
Oh, yeah.
And turn it into an iterator. So semicolon there, okay. And yeah, it would wrap this and turn it into an iterator.
Okay.
Wrap this, no, wrap this in a parentheses and then turn it into an iterator. Just like you've done here. There you go. No, after the parentheses.
Oh, yeah. My cursor was in the wrong place. Wait, I don't have access to it.
Into iter.
Ah, into iter. Into iter.
Okay. Semicolon. Great. So what problem we have now?
It says expected U32 found strikes the OPS range.
So we have an iterator, right? So we're passing an iterator.
Yes.
And by the way, here this is not included.
Oh, is it not included?
But you can
If we
say
just do
yeah,
a dot.
4.
Oh, 4. Okay. I thought.
But you can
dot
also say
goes until
this.
the end of the. Ah, okay.
You can also say this.
I see. Okay.
So here we have an iterator, but we cannot accept iterators, though we can accept slices. Why we cannot accept iterators?
Because I'm guessing the iterators are not the actual object itself is a pointer to
The
the
thing is
object.
about iterators, they just give you one value after the other. It doesn't have to be contiguous.
Ah,
You see?
I see. Yeah.
So we cannot work with this.
I see. Yeah.
But can we actually turn an array into an iterator? And can we turn a vector into an iterator? Can we? We can.
I mean, why not?
Yeah. So to actually be able to use all of these, what should we get here? We should get an iterator instead.
Yes. Ah, I see.
You see, so we don't need generics here, right? So
We can just get an iterator. Yeah.
So we gotta say impl and then iterator.
Oh dear. Not impl again.
Just say iterator with big I, right?
Iterator.
And
Okay.
inside angle brackets.
Oops.
And inside of the item is equal to with a big I.
Item is equal to.
So what the item that we want to get for every item from the iterator? What's the type of the item in the iterator?
U32.
Exactly.
Oh, okay.
So now Control S. But yeah, okay.
But that wouldn't work.
All right, so now
because
this
we
works
haven't-
here. So what we should do
Yes.
here, we should actually turn this into an iterator. Dot
To
into,
iterator, yeah.
or dot iter, right? Dot iter. There you go. Same thing here.
Does it work? It's still giving an error. It says expected integer to be, but it yields reference to the.
Just do this first of all. S dot iter, 3 number dot iter.
Okay.
And here, what's the problem that we have here?
Oh, we are getting an iterator. And
So we're already getting an iterator anyways,
yeah.
so
Yeah.
Control S.
Okay. So that's
Okay, cool. Now what is the problem with this?
It says
guy?
required.
Cargo
by a
R.
bound.
See cargo R.
Yeah, wait, let me actually clear this first because I don't understand what's going on.
Yeah, expected error
Okay,
to be an
that's
error.
right.
Interesting.
Be an iterator that yields U32, but it yields reference
That's
to an
actually
integer.
weird.
I'm guessing we have to dereference it
Nah.
because it says
This
yields
should actually
U32.
work. I'm not sure why it's complaining. Oh, my bad. I see. So the default value in Rust is not U32, it's I32.
Ah, okay.
And we didn't give an explicit type here. Actually...
But still doesn't.
Well, let me just give it an explicit type then.
Yeah, I32.
What the heck? Are you kidding me? 3 number... Oh, required by bound in sum. I think it's maybe because we're actually using the .sum function. So let's do something easy. Hold on a second. Maybe it's because of generics. No, it's not. Interesting. What if we don't do this?
Okay.
Huh. Oh, I see. So this iter right here, it actually gives you references to the items, not the items themselves. So you gotta consume the thing, right? We gotta say into iter to consume
I
it,
see.
right? So we can get the items themselves
Yeah.
instead of references to them, right?
Yeah.
The same thing here.
Yeah.
Into iter. Now try this out. Does it work?
Nice. Yeah, it does work.
So now our thing works with any iterator, no matter if it's a vector, an array, an iterator, a range. You see?
So as long as we pass into it like a bunch of values,
Yeah.
it will just iterate through them
Yep.
and it will create a sum.
Pretty
I
much.
see. So this way we don't. Although, can we make it so that the type is not defined, but the type is deferred?
Generic?
Yeah.
We can make a generic here. So make a generic here. How did you do it before? Brackets? Angle brackets?
Yeah. Brackets, and we just say T. And
But you
then
know what?
here
Okay, go ahead.
that's T.
Alright, cargo run.
And it
You're gonna
still
have a little
works.
problem here. Huh.
Oh.
Weird.
The program was like, sure.
Did you save? You didn't
Yeah.
save it.
Oh
There
wait,
you
no,
go.
it didn't save. Damn it.
I knew
Okay.
it was
So
coming,
it
bro.
says
There's no.
a value
My
of type
brain
T cannot
faltered
be
right there when it didn't happen.
He was like,
Sick
what
fall.
the hell? How did Rust?
Cargo
Sick
arm.
fall.
You're not
Okay,
supposed to
that's-
do that. Okay.
We're not supposed to compile.
So
Okay,
it's.
it says
what is-
value of type T cannot be made by summing an iterator over elements of type T. Yeah.
Okay, so what is the problem?
Okay.
What it's saying to you?
It says required by bound in an
So
association.
the thing is, you don't know what T is. It can it be addable or not? You don't know if it's summable. You know. You know, it can be a cow.
Well,
it
yeah,
can be a
I'm
number.
guessing-
It can be whatever.
Yeah. Yeah.
A
I'm
real
guessing
cow,
it
by
needs
the
it
way.
to be yeah. Real cow. Interesting.
So
But can't we make it so that be a range of different types?
yeah, you need to constrain it to some type T that is actually addable, right? That is summable.
I see.
So here, what
Yeah.
it said, value of type T, cow in the form of a steak. Hello, Robert. Welcome to the live stream. So value of type
dear.
T cannot be made by someone required by a bound in. Note required by a bound in what? Read the error.
Required by bound this iterator sum. Oh.
And
so
what it says
implementation
down
of
there, it
sum
actually
will
tells you
give
the. It actually tells you the solution down there.
Oh,
Rust
Rust
compiles it,
explain?
Chad. No, without Rust, you actually
Oh, okay,
have
okay.
it, bro.
STD. Oh, interesting.
Magic.
That is so cool. Okay, so you can just say STD iter sum, and it will just
You can just compile,
allow-
like add it, import it, replace qualified path with use.
yeah.
So what you're saying here, you're actually bounding or you're constraining your type to be summable, so you can actually use this sum function. Because you cannot use this sum function if you didn't declare that this T should actually be summable.
I see. I see. Interesting. Wait, let me check out the. Wait, where is it? Sum function. So what does it get in? It gets S, and the S is of type. Where is the S? Wait, what?
Where?
Oh, where? Self is sized. S is self sum item.
So this is the bound. So you can actually, if you come back to your code, you can use that where instead of putting it inline. So
I
you
see,
can you
okay.
can cut this and put it after that, after where, you know, here. So like this,
see.
right? So you see your code, right?
Yeah.
Oops. You can also do it this way. It's the same thing, just
Huh.
when your
Yeah,
bound
it's
is
just
big,
different
you
view.
you want it to be more readable like this.
Yeah. Interesting.
So you
So
know,
you
you
can
see
make
what
it
is this?
kind of
This is
generic.
actually concepts in C++.
Ah.
You see when you see
okay.
when you use some type that is not summable in C++ and you're using
Yeah,
templates,
yeah.
you're just gonna get some garbage. But if you use C++
Yeah.
concepts, you're actually gonna tell you that you know this concept have failed. It's not summable,
Mm-hmm.
you know.
Yeah.
And the same way, it's gonna tell you in Rust. Try to make this instead of this. Make it take a bunch of strings. I'm not sure.
Okay.
I don't think some strings are summable. So try that.
I mean, are we talking JavaScript?
No, this is Rust.
Because anything is possible in JavaScript.
Yep. That should be fine. Okay, Control S.
I
And
think I
see
control
what
S like
happens.
5 times.
So,
Ah.
What's the
so
error?
it says the bound. It says value of type string cannot be made thumbing. Yep, it just says that the type is not compatible with the function sum.
there you go. So instead of
Doesn't.
giving you template garbage, it actually tells you exactly why that's the case, why it didn't accept it.
Interesting. It even tells you all of the implementation of the sum. It says I size as sum, I
Yeah.
size as sum,
So these are
and
the
then
possible
the
ones that you can
72
actually use.
others.
Yeah, the
Yeah,
ones that are
and
possible.
72 others. Oh, dear.
Required by a bounding sum. It tells you exactly which function. Yeah, there you go. Required by a bounding this function sum.
Yeah.
So you see why this is important to actually declare what properties
Yeah.
you expect on your types. Because right now
Yeah.
you cannot use, you're basically constraining it to types that are summable. So you cannot use it with types
Yeah.
that are not summable. And you get beautiful
Yeah.
errors like this.
Yeah.
So basically in Rust, in generics, you cannot assume that they're summable, you know, because it could
Yeah,
be
yeah.
anything. If you want it to be
Yeah.
summable, then you have to declare that they're summable. You see?
Yeah. That makes sense.
All
That's
right.
cool. Okay.
That's all right. Pretty nice. Can you try to do it on your own instead of dot sum using iterators? Numbers
Oh
dot.
boy. Oh boy.
So what we want to,
numbers.
what's the operation that we want to do here? We want to reduce that iterator of items into one item.
Okay.
And there a
Reduce.
closure.
Closure was 2 parts.
There's also
was it?
fold,
Yeah.
yeah. Okay. And what's the closure
Yeah.
takes? You can check out the declaration of reduce. Control
yeah,
and click
okay.
on it.
So it says self and then F, so type F and then returns option. Okay, so it will take self. Wait. Oh,
No, self is already taken. You're already
oh yeah,
using
yeah, yeah.
dot,
So
right?
self is calling it.
Yeah.
Yeah, true.
Now the F.
Uh,
And where F is what?
F.
In the generic, where F is what?
F is F. Oh.
Fn mute. Yeah, read that thing.
Oh, I see. Okay, where self is sized and then F.
Is Fn mute?
Fn mute self item. I see. So
So what you're gonna get there? Which arguments you're gonna get there? A and B, two arguments. So it's a binary function.
A and B.
A and B,
Okay.
yeah. Then you need to return self item. No, A comma B here.
Oh.
And then what you need to return?
Why are we?
You need
passing
to return
A
one
and B?
value. So say A plus B there. No, why C here?
Or return
Okay.
to
Say A plus B there.
A plus B.
Okay, and save and run. Alright, so we have a problem. What is the problem there? So we don't have sum anymore. We don't want to use sum anymore because we're not using that sum function. So let's just remove this for now. Okay, so compile and see what it tells you.
Here. Pile. Okay. So it says
Here's the first error.
the first error cannot add T to T. Numbers that reduce A, B cannot add them. It says fn sum
Help what? What it says in
add.
help?
It says consider restricting the type parameter T. Oh, wait, you removed the T
Yeah,
for
sum.
sum.
So we don't want sum anymore.
Okay.
We're doing it
Okay.
ourselves. We're not using the sum function.
Mm.
Okay, go ahead. What you gonna
So
do?
we have to restrict them
The type,
into...
yeah, to be addable. So
Yeah.
you should be able
Yeah.
to add T to T. You cannot just
Yeah.
assume that they're addable. So what?
Yeah.
Do what the
Well-
compiler said, right? It tells you exactly the solution.
Yeah, it says fn sum T. And then, okay, let's do that. Colon.
Just say add. Just say add it with the output. You can import it.
There. Then what equal
And why we need that output in your opinion?
isn't
Let me import it.
output Hmm.
And here we need an inwrap because this returns an option.
Ah.
Why it returns an option? Because basically reduce goes through all the numbers in the iterator.
I see.
And
Yeah.
use this closure right here to reduce them. So like if it's 1, 2, 3, what would happen, it would call that function with 1 and 2. So you'd get 3, and then it would call 3 with 3.
I see.
And it would get
3 with
6.
6. I see.
But what happens if you have no items?
Oh. It can't add them, I see. Yeah.
So that's why it returns for you an option.
I see, okay.
And you need to inwrap since if we inwrap though, it would just basically crash if there is no items in this case. And there you go.
Currently it does return, okay.
You can also say instead of a plus b, maybe you can say add. Try now.
Interesting, okay.
So we're basically calling the add function in the add trait. We could have also said this t add.
Yeah, because
but you can also do it
that
like
type would have the add implemented.
Exactly. You see?
I see. Okay. So essentially in here, we are calling that we are only accepting the types that has the function add implemented.
So yeah, they are addable. But also there's another constraint here about output. You didn't tell me why that's the case here.
Well, the output should be the same type as the input.
Exactly. That's what we're saying there.
Yeah.
We're saying that the output should be like when you add t and t, we should get back t, nothing else.
I see. Nothing else. Okay.
If we wanted to allow for different types, then we should say we declare a new type u, for example, and then we say equal u here.
Okay. Interesting.
Pretty cool.
Super cool. Yeah.
There's also another functional iterator adapter.
Yeah.
There's fold instead of reduce.
Okay.
Fold.
Oh.
Now fold, instead of taking one closure, it actually takes an init value and a closure. So let's say starting by 0 and then
and end with
a comma b, just like before, you know, we could just say add. This is another way to do the reduce. But actually, like, you can basically implement reduce using fold and the other way around. So, but the thing is about fold, it doesn't return an option. It returns the value. Just like why in your opinion? Because we have an init value. We're starting with a value.
We have a 0. Yeah.
But the problem that we have here, compile this and see what is the problem we have here.
Oh jeez. Well, it's gonna scream at me.
Okay, so what's the problem?
Mismatch type expected. Oh. Yeah, it says that the 0 is not of type T because type T is generic. It can be any type, but
exactly
0, I'm guessing, is I32.
So how are we gonna do this? You see the problem?
Interesting. Yeah.
You did not notice this in template. The compiler is gonna tell you exactly what's up. So we need to basically constrain T to also allow us to give us 0, you know.
Yeah. Oh.
You see?
I see.
So the problem though, we have to make it our own or use a library that is quite popular. It's called num traits. So say cargo add num num and then underscore traits. Right. There you go. Cool. So now we have some more traits on our toolbox to use. We could have implemented them on our own, but there's no need. Plus,
interesting.
To add another constraint. Plus 0.
Oh, so all of the types that have 0 in them.
It should be able to give us 0, but hold on, let's actually cargo R real quick so we can compile the library. Okay, so use num trait 0. We have to import the trait to be able to use it.
Yeah.
And there you go. But now we still have the problem of 0, right? But what you can do
But
right now...
here, but we can just say 0.
0 what? That's
Okay.
the trait, not the function.
Ah,
So,
0.
well, namespace?
Namespace. Then 0.
No, what's the name of the function that is inside of it?
Old?
0, pretty much.
Oh, 0. Okay. Interesting. Okay. Wait, no. it
Expected
still
type
says-
error found even. Try to compile this.
Okay.
Expected this type parameter found fn item. Why cannot? Interesting. Weird, but we can say t0.
No, it doesn't like that either.
Really? Are we? I think maybe we're. Why it doesn't give me good auto completion stuff? Hold on a sec. Let me restart my Rust analyzer.
Alright.
Sometimes when you add a new library, it doesn't work so well. Okay, there you go. Okay, now I actually. Hold on. What? Mismatch type expect. Oh, my bad. We need to actually call this. We don't want the function, you know. We want to.
Function,
to
I see.
actually call-
Okay.
Or instead of t0, it could also say 0, 0.
Yeah.
So try now.
Okay, it returns an additive identity. Okay.
And there you go.
Okay. However, let's just say this vector is empty. Save. That should return 0. Yep, there we go.
So we always start with 0, so we don't need that option and such, yeah.
Cool.
But,
That was cool.
yeah,
Okay. This num trait is interesting.
yeah. It contains a lot of traits for different numbers. In fact, there's even a library, if you search, there's even a library for all algebraic types.
Oh.
Rust Alga, it's called Alga. I'm gonna send the link in the chat, this live. Look at that. It actually have all sorts of crazy traits for all algebraic types.
Oh, Jesus. Yeah.
So like in higher level algebra, you cannot, in your generic stuff, you cannot, like in your generic theories, you cannot, what is it called? You cannot assume that your, like the entities that you're using implements that have some certain properties. You have to actually say what those properties are. So we use algebraic properties, you know, stuff like that. Either way, that's just high level mathematics.
Yeah.
So
Interesting. Nice. Nice.
okay, so but you see here, we have a little trade-off. So we can either add this constraint to our type, so we only allow types that implement 0 trait. Or we could actually remove this 0 trait and make this an option T, and use, instead of fold, we can use reduce. And we don't need the init. So when it's empty, we'll just return none.
Okay.
So we just have a little.
Wait.
So trade-off.
Return none.
Yeah. Some or none.
The?
Some or none.
Ah, I see. Some or none. Okay.
Depending if it's empty or not. And then we're not gonna need the type T to implement 0.
Type T,
We just need it for add. So it's a trade-off, right? Do you want to accept more types?
And I'm guessing we kind of allow for more types as well.
Exactly, yeah. The less constraints you have. So we see how that goes.
Cool. That is actually cool. That's really interesting.
Yeah.
The fact that you could just do plus, that was kind of mind-blowing.
Yeah, you add new constraints basically. Like you can make it addable and dividable and so on.
Yeah.
Or if you don't want all that work, you could just use num traits num. And then you basically tell it anything that looks like a number, it is a number. But then, of course, you would accept less types,
Yeah, I'm guessing you can't because of the fact that. Wait, you deleted that, so that the output can be anything now.
I mean, the type parameter t, if you see num, it actually already takes some. Like basically, it is implemented for all all numeric types, basically. So you're
Yeah,
basically
but
telling
like
that
I'm
anything that is a number that implements
yeah,
0, that implements 1, that implements add, sub, div. So we don't have
yeah,
to declare each one of those.
yeah. So my question is, can you like pass in a U32 and another U32 and then get a U64? Because that doesn't constrain you for your output to be the same as the input.
It does. I mean, t is t. What do you mean?
Oh, I see the option T. I see. The return says option T. Okay, okay. Well then, this like when it was like this. Okay, when it was add.
Yeah.
Why do we need the output if you're already doing option T anyway?
You need to declare it. To declare it in the traits themselves, not in the return.
Ah, okay, I see. Okay.
You could also do this like this. So where
Yeah, I see.
t, just like math, kind of, where
Yeah,
t
yeah,
should be addable.
yeah, I see. Cool.
So yeah,
Interesting.
now you're
Nice.
ready to go to the next stage in the vector, in your vector struct.
In my vector journey.
So now
Alright.
you learned slices, you learned
Yeah.
some trait stuff, you learned some generics,
Yeah.
and you learned also
Generics like
iterators, some more iterators.
yeah. Some more iterators
So
and some functional stuff.
yeah. Okay, so instead of index mute and this stuff like here, why can't we just tell Rust that we basically want to treat a vector like a array? Because right now, even though a vector just wraps this type array, it doesn't really allow us to do indexing unless if we actually do it ourselves. So can we actually kind of say to Rust that we want to kind of treat vector as an array, first of all? So we don't have to implement all of this stuff. Anything that is implemented for array, it would be implemented for our vector. You see what I mean?
Yeah.
So we can actually do that using a deref trait. So we don't need any of this. You can just implement
Okay.
deref direct, like impl deref. Try it.
Okay. Not there. Oh.
Deref with the big D. There you go.
Okay.
For
Vector.
yeah,
And that would be T.
comma.
Blank. Oh,
Just
yeah.
copy these stuff, really.
Yeah. I already. Not already.
Copy the
Oh,
declaration.
do I need the const?
Yeah, copy the declaration.
Okay. Okay.
Not there. That's the actual value. Control Z and puts it here, the declaration in the impl.
Oh, yeah.
And then deref needs to import. Let me import it. But okay, so let me implement the missing stuff. There you go. So what the target is, what we're gonna deref to, we're gonna deref into an array.
Ah, I see. Okay.
Equal to type
So
target.
we're changing the
type target equal to the array type.
Yeah.
So our array type, just copy it. Type target, okay.
It would be T.
Let's just call it scalar. But anyway, it's fine, I guess. Or yeah, okay. And now what you're gonna do next?
Hmm.
So you need to implement this deref function.
Yeah.
What you gotta give it?
So
A
that
reference of what?
is self.
Target? What is
Yeah.
self-target? So a reference to the array.
So an array. Yeah.
So do it. Give it the reference to the array that we want to deref to. So reference of what? Self dot?
Reference of self. Dot
0.
0.
That's it. That's it. We want the actual reference to the array. Yeah.
Oh, I see. Yeah. Okay.
So now let's forget about
Is that
this
it?
for a second. And now
Okay.
you can actually do that index. Try it.
Wait, you can?
Yeah, cargo R. Now you can literally
Holy
do
shit.
anything you can with an array. You can do it with the vector now. Since you implemented deref for the vector. You have, in debug mode, you have runtime checks for the length, for the bounds.
I see. Okay.
Only in debug though, yeah. Or I think maybe even release, but yeah. So now anything you can literally do with arrays you can do. You can also take an iterator and sum it up.
Oh.
Try this out. But of course it needs some type here. Let's say, f64. So we want to sum it to f64.
Yeah.
And there you go.
Yep. There's
So we can also use iter. We can take a slice too.
So essentially what we did is dereferenced the vector into a reference of an array.
So yeah, when you implement deref, so the compiler automatic, like when you say a dot something, the compiler automatically try to deref. If that deref doesn't work, then it deref to the next thing. So array itself could have its own deref and so on. And it keeps on going that chain until it finds some good. So instead of, having, you see in C++ when you actually have to do this,
Yeah.
Struct this.
Yeah.
In Rust, it would just figure it out for you. That's the deref. You see? You just say dot .a and it would figure it out the chain of the deref. So you don't have to say this. That would be done for you automatically by the compiler, right?
Yeah.
So yeah.
All right.
But we cannot do this because it's mutable. So we basically just need the mutable version, deref mute, deref mute. This would be mutable. You need to import this guy. And it's not a member. We don't need this. Same thing, associate type.
Yeah.
And here mute, yeah.
And that self is mute as well.
Yep. Do it.
Yep.
And Calabra is this behind? Yeah. Great. And there you go. Now we can actually also do this.
Okay.
Now check out all the members you have in A that you can do with A.
There we go.
A dot and see the autocomplete.
A dot.
Look at how much stuff you have now. You didn't have to implement any of it.
Yeah. A bunch of
So it's inheritance without inheritance.
Nice.
You see?
Cool. That's actually, that deref interesting.
Yeah.
Nice.
So what if we want to allow to add, or let's start simple. What if we want to be able to say minus a?
Minus a?
Yep. So
what do you mean by minus a?
So basically minus this vector, give me the negative version of that vector.
Oh, I see, okay. It says must implement neg. Oh my god, another impl?
Yeah.
Or neg?
I'm gonna do it myself since there's not much to learn here, I think, since you already know.
Yeah, it's
now
the
kind
same.
of the. So impl neg for vector. Well, I can just copy this guy right here. Oops.
4.
And we're gonna copy that declaration here and control implements missing members. Type output is equal to scalar, and the negate would be vector new minus self dot, well, oh, my bad, I see. We need to construct a new array. Interesting, actually, huh? So an array of any length. I see. But we do need to, okay. So we can say a cd array from fn. You remember this function?
Yeah, yeah.
Okay, this would give us actually the index that we're populating right now, and then we could just use it, self minus self. But before that, what's happening right now? Found struct, mismatch types expected. Oh, my bad. It should be self, yeah. Okay. Cannot move out of type. A non-copy array cannot move out of here. I see. So basically what it's saying, because if we do this, we are going to move that value out of the array, which is not possible because it doesn't implement the copy trait. But what you can do, you can clone it too.
Clone it.
But even if you want to clone it, you cannot, because there's no method in T that is clone. Unless,
oh dear. Oh yeah.
if you say that it should be clonable.
Make the, yeah, clonable.
But what's up with this guy? Oh, my bad. Clone. There you go. Otherwise, you could just say copy. So you're basically saying that it's cheaply copyable. This is actually a template
Only
in
the,
C++. It's called,
yeah.
not cheap. It's called, I think, trivially copyable.
Yeah, trivially copyable. Yeah.
Yeah, if you check C++ trivially copyable, you're gonna find it. There, it's trivially copyable. It's CDs. There you go. That's literally it.
Yeah,
you have to do it. You have to do it like this in C++.
Yeah.
Static assert.
Yeah.
Trivially. Look at that syntax.
Yeah.
So yeah, there you go. That's copy. But
cool.
Of course we're gonna, like, for example, vec is not copy. It's only clone because it's not, you know, trivially copyable. So better use clone if you can.
Clone, yeah. All right. Cheers. Thank you very much.
Yeah.
It was very informative. Another session of interesting stuff.
Yep.
Cool. Wait. You have to put neg as well because only certain types allow for negative numbers.
Yeah, there you go.
Okay.
Now if we do minus a,
yeah,
you get the minus
G. Oh yeah, minus 1.0. Nice.
Yeah.
Cool. Thank you.
So
it was fun.
Yeah, I think you're tired right now.
Yeah, I'm pretty tired at this point.
So.
It's like 3 a.m.
You've learned pretty much a lot right now. You learned.
Yeah.
What was it? Stir versus string. I learned cow. You learned some iterators.
Vector,
some more iterators.
Some more iterators. Yeah.
And what else? Generics. Sure. Some more traits.
Oh yeah, traits as well.
And what else? Operator overloading using traits. What else? I think that's it, maybe? I think that's it. So,
oh yeah, tests.
Yeah, tests. How to create tests. Anything else?
I don't think so. I think
that's basically what was it.
That's a lot of stuff for one session.
There you go.
Cool.
Yeah.
cool.
That was great.
Thanks for that.
You're
Cheers.
welcome.
I think like for the future we should kind of have a session where we go through creating a kind of like a simple 2D game engine with Vulkan.
Vulkan.
With Vulkan, yeah.
Simple.
Yeah, yeah. Just a simple.
Just 1,000 lines, yeah.
Yeah. No, just
For a
one
triangle.
liner.
I mean, sure, why not if you want to.
Yeah, because I've been trying to get into Vulkan a bit, and
Sure.
like it is a really steep learning curve.
Very
And
steep learning curve, yeah.
yeah, yeah.
I would recommend
But
WGPU though. I would honestly teach you WGPU instead of Vulkan if you want to in the
WGPU,
future.
what is WGPU?
WGPU. It's a new. It's an implementation of the web GPU spec.
Ah, I see.
The new one, the new web GPU spec. So you know
Is
WebGL?
that the one that? Yeah, is that the one that works with Wasm?
Yeah.
Ah.
So this is the new
I see.
GPU API for web, right?
Uh-huh.
Spec, and basically WGPU is the Rust. It's implemented in Rust for the web GPU spec. WGPU. It's used by Firefox. Chrome
okay.
Chrome uses though their own thing, which is called
Yeah.
Dawn. Yeah, it's called Dawn.
Ah.
It's implemented in C++. Though even though WGPU is implemented in Rust, it's also have a C API, so you could use it anywhere.
Ah, okay. Yeah. Oh. Okay.
And basically WGPU, depending on the platform, if it's web, it's gonna use the web, the web GPU spec, right? If
Yeah.
it's let's say Windows or the other, it would use Vulkan.
Native.
Depending on which backend is available, it would use it, right? So you don't have
Wait,
to worry
cool.
about it. It could use Vulkan. It could use the Metal for Mac OS. What else?
Does it have a DirectX implementation
Yeah,
as
DirectX
well?
2. It does.
Wait, really? Okay.
Yeah, DirectX 12 even, and I'm
Oh.
not sure if it's have at 11, but yeah, DirectX 12
Oh, okay. I
or
have to
Direct
figure
3D
out
12. Sorry, yeah.
Yeah, Direct 3D. Yeah.
I want to make 3D game for potato PCs or GPU. Yeah, you could do that with the web GPU too, WGPU. So I would honestly recommend learning WGPU instead of Vulkan or any of these.
Yeah.
Pretty much. I mean, we can
I mean-
sometime in the
I mean,
future.
to
if
be
we want.
honest, like if you know like one, like the kind of the skills are transferable. then-
Not much. Depends on which.
Is it? Oh,
Like
okay.
Direct 3D12 and Vulkan are transferable between them, right?
Yeah,
The
yeah.
OpenGL and Vulkan, they're different beasts.
No, yeah.
Of
yeah.
course, other than the graphics, of course,
mean,
the graphics
Metal-
knowledge stays the same, yeah.
Yeah,
The actual like rendering equation, etc. That of course would stay the same, but like the actual API, oh my god, totally different. This is a
I mean,
state
Metal
machine.
Vulkan
Vulkan
is
is
essentially the
objects
same as
oriented
well.
and very low level, very verbose,
Yeah.
and you can control every single detail of what's up.
Yeah.
It's like, implementing a Vulkan render is like implementing a driver pretty much, because basically what
Yeah.
happens is the OpenGL driver is pretty huge, right? And full of heuristic stuff to just guess what you're gonna do, and if that guess doesn't
Yeah.
work, then you take a hit in performance because they gotta stall everything and try and do it again. But in Vulkan, you do everything yourself. So like the Vulkan driver is like it's shallow, right? There's not much
Yeah.
from the hardware.
Yeah. It lets the
And also,
developers
yeah,
take care of
and also OpenGL, you basically feed it with GLSL source code, right?
Oh, okay.
Which is not great, because every driver have to make a compiler themselves for GLSL, and
Yeah.
so your code can compile on one GPU and the other not, because there's some
Yeah, yeah.
rules that some compiler allows it, other one doesn't, and so on.
Yeah.
Which was a pretty big mess, and you could have like some problems with that. In Vulkan though, you just compile your shader to SPIR-V, which is an intermediate representation,
Yeah.
like LLVM IR, if you know that.
Yeah.
Kind of a bit similar to assembly, or but not really
Yeah.
assembly. You got the point.
Yeah.
And then you would feed that to the driver, which is much simpler,
Yeah.
so it's easier to get right. But yeah.
Yeah. Cool. Okay. Oh, I'll have a look at WGPU as well because it sounds interesting.
Yeah. I would honestly
Yeah.
recommend WGPU if you want that, and instead of Vulkan, OpenGL, Metal Direct. No need for those.
At first, I just thought WGPU is just for the web, and I was like, I don't really want to make things
Yeah,
for
it's
the web.
not for
But
the
you
web.
mentioned
Yeah,
it.
it's
Yeah.
just the
Yeah.
spec. WGPU it does implement the spec, but you can use it even
Yeah.
in desktops with
I see.
mobile
Okay.
and everything else.
Yeah.
So yeah.
Cool.
Any questions?
Awesome. No, all the questions have been answered. To be honest, it was pretty cool evening again,
Yeah.
or night, or morning. Oh, yeah. Anyway, thank you so much again,
Thank
and
you. You're welcome.
for another session.
Yeah. That was amazing.
Yeah, cool.
All right, so that was it, guys, for this stream. Thank you for watching. Thank you for tuning in. Thanks for Woji Girin, Stars, Daniel Galano, Robert, me too, Kodo Chaku, right?
Yeah,
And yeah, thank you guys for joining in. Thanks for Beirut for today's session,
and thanks to you.
and thanks to me.
Yes.
Thank you guys. Have a good day or a good night, and see you later. Goodbye, everyone.